This is the live PID data using the scan tool for the 1998 Ford Ranger. It is currently running at approximately 900 RPM. The loop has closed itself.
We've had it running for a little bit, so that loop is closed. And these are our O2 sensors. They are running at 800 millivolts, which is exactly where we want them. Means we're running real good. And yeah.
As we go down,
Short fuel trim data. It's adding 6 and 5 on the 2 banks. Long term, it's adding 8 on those 2, which is still within spec. Pulse width is still good on that. Engine coolant temperature is 145, which is good because we're still warming up. Oh yeah, sorry. Engine coolant temperature is 145 right now, which means we're still good. DTC count is 1, just because we have the door open. And then, I don't want to go down on me right now.
this is our emissions tab for our PIDs on the 1998 Ford Ranger.
Not all PIDs are supported on this vehicle just because of the age of it, but we have our drive counts. We have our engine coolant temperature in Fahrenheit is 183, which is right where we want it at, and that is 0.72 volts coming from that sensor. No faults on our ECTs. Our EGRF is good. Our evap is off. Don't have any evap faults. We don't have any idle air controller faults. That is still running good. Our idle air temperature is 66 degrees, or 3.24 volts coming from that sensor. Our injectors are all good. We're running in closed loop, no misfires. RPM sitting at 900. Throttle position is at 0.89 volts, which is basically closed. That's where it should be. Yeah, that's our emissions.
This is the Ford O2 sensor reading the oxygen levels before the cat. This is the secondary O2 sensor that reads the exhaust after the cat.
So this is a mass airflow pressure sensor, or a MAP. Some vehicles incorporate a MAF sensor, which does airflow, but this one does air pressure. This has 4 wires. It reports back to the PCM. It's an input, not an output. Yeah, that's your MAP.
This is the idle air control valve. It is an output controlled by the PCM, and this one does not work. This is the throttle position sensor. This is an input that receives the angle of the throttle and sends that to the PCM as well.
The angle of the throttle plate's actuated by this right here. It's a little hard to see, but it uses the throttle cable, and yeah.
This is the intake air temperature. It is after the intake but before the throttle. It is an input to the PCM. This is the engine coolant sensor. It is an input to the PCM. Here is the location of the PCM. It is the brains of the vehicle, takes all the inputs and figures out what to do with the outputs. This is the EGR valve. It recirculates unburnt oxygen and fuel vapors to create a cleaner burn, and the sensor on top is an input to the PCM. This is the ignition system. It is a coil pack that sends spark through 2 wires at a time, through the spark wires into each spark plug in all the cylinders. This is the voltage measurement for the DLC on the 1998 Ford Ranger.
We have 7 pins, so we don't need the other 9.
Correct. So on pin 2, we have a ground. Pin 4 is a ground. 5 is ground. Pin 7 is dead. Pin 10 has 4.9 volts. Pin 13 is dead. Pin 16 has 12 volts.
So for this test, we're going to be demonstrating how the PID can change if you manipulate or unplug a sensor. Alright, so I'm going to have my assistant Dylan show you right now. That's at 68 degrees or 3.17 volts for the idle air intake temperature. And once it's unplugged, drop down to -40, and we also have 4.74 volts going, should be going through that sensor, but yeah.